flight had taken 10% longer to evolve on Earth, it wouldn't exist at all.
For nearly half a century, NASA's Voyager spacecraft has journeyed through space, beaming back secrets from the cosmos. Recently, a startling message reached Earth, sparking curiosity and concern. NASA has revealed that the probe encountered something inexplicable out there in the vastness of space. What exactly did Voyager stumble upon? And what would it mean for us here on Earth? Join us as we uncover the secrets behind NASA's warning about Voyager 1's deep space encounter. NASA's Voyager spacecraft are incredible marvels of human ingenuity. These machines, born in the 1970s, have defied the odds and ventured beyond our solar system, exploring uncharted territories and beaming back revolutionary discoveries to Earthbound scientists. What's truly mind-boggling is that despite their age, these spacecraft have a memory capacity that's 3 million times smaller than your average smartphone and transmit data at a speed that's a whopping 38,000 times slower than the lightning-fast 5G internet we're accustomed to today. Despite these limitations, or perhaps because of them, the Voyagers have become legends in the realm of space exploration, achieving feats that were once thought impossible. And just when we thought we knew everything about them, they surprise us yet again. Recently, the Voyagers made a discovery that has sparked a heated debate among scientists. Some are cautiously optimistic, hoping it's a glitch in the system rather than a genuine finding, while others are excited by the prospect of a groundbreaking revelation. What adds to the intrigue is the way this discovery was delivered. It's almost as if the Voyagers had to overcome a cosmic obstacle, battling against an unknown force to ensure that their message reached us here on Earth. Let's start by exploring the remarkable backstory of these extraordinary probes that have tirelessly gazed into the vastness of space on behalf of our planet. The genesis of these incredible spacecraft can be traced back to a celestial phenomenon that occurs only once every 176 years. During this rare event, the 4 largest planets in our solar system, Jupiter, Saturn, Uranus, and Neptune, act as celestial guides, creating a gravitational slingshot effect. This cosmic dance essentially propels a spacecraft forward, harnessing the immense gravitational forces of these giant planets like an invisible celestial rope. However, this alignment comes with a significant caveat. It happens just once in nearly 2 centuries. Despite this limitation, the alignment presented an unparalleled opportunity for interplanetary exploration. NASA, recognizing the magnitude of this celestial event, seized the moment in the mid-1970s. They meticulously crafted 2 identical spacecraft to embark on this epic interstellar journey, capitalizing on this golden window of opportunity for interplanetary exploration. The Voyager spacecraft embarked on their epic journey from Cape Canaveral, Florida. On September 5, 1977, Voyager 1 soared into space, propelled by the Titan III-E Centaur rocket. Just weeks later, on August 20, 1977, Voyager 2 followed suit, commencing a parallel odyssey into the depths of the cosmos. Initially tasked with exploring the gas giants Jupiter and Saturn, along with their captivating moons, these intrepid probes exceeded all expectations. Their mission expanded to encompass the farthest reaches of our solar system, venturing into uncharted territories beyond the realms of the gas giants. Along their historic journey, Voyager 1 and Voyager 2 achieved remarkable milestones. They have outlasted any other spacecraft in history and journeyed farther from Earth than any other human-made objects. Most notably, they breached the boundaries of interstellar space, becoming the first creations of humanity to transcend the sun's influence and venture into the vast expanse of our galaxy. Their expedition into interstellar space, spanning over 12 billion miles from Earth, has yielded a wealth of invaluable data, leaving scientists in awe of their discoveries. One recent revelation, which we'll explore in detail shortly, involves a warning signal detected by these space pioneers and confirmed by NASA scientists. The Voyager's exceptional capabilities are owed in part to their innovative use of self-powered radioisotope thermoelectric generators, RTGs, which have sustained their operations across the vast distances of space. These nuclear batteries, also known as radioisotopy, power systems, harness the Seebeck effect to transform the heat from decaying plutonium into a steady stream of electricity. What's truly remarkable is that these RTGs operate seamlessly without any moving components, greatly reducing the risk of mechanical wear and tear. This characteristic makes them exceptionally reliable for enduring the harsh and distant environments encountered during deep space missions. One of the standout advantages of these generators is their independence from solar energy. Unlike solar-powered systems that rely on sunlight, RTGs can function efficiently in regions where sunlight is scarce or non-existent, making them ideal for missions venturing into the depths of space. However, there's a caveat to this impressive technology. Over time, the decay of plutonium within the RTGs leads to a gradual decrease in power output. Despite this natural degradation, the overall mission integrity remains intact, thanks to the proactive measures implemented by NASA engineers. To counteract the diminishing power supply, engineers have strategically disabled heaters and non-essential systems that have no bearing on the spacecraft's essential flight operations. This proactive approach ensures that the Voyager spacecraft continue their mission effectively, navigating the cosmos and delivering invaluable scientific insights back to Earth. The Voyager spacecraft was ingeniously equipped with a unique 8-track tape system for storing and playing back data, a technological marvel that still astounds today. Now here's a breakdown of how this system works. First, the array of scientific instruments aboard the Voyager probes captures a diverse range of data, including images, audio recordings, and various measurements. This raw data is then converted into a digital format for processing. Next, the digital data undergoes serialization and is meticulously stored on the specialized 8-track tapes. These tapes feature 8 parallel tracks, ensuring efficient and organized storage of vast amounts of information. When it's time to relay this data back to Earth, the onboard computer autonomously reads the relevant data from the designated tracks on the tapes. This read data is then transmitted through the spacecraft's communication system, primarily utilizing its high-gain antenna to beam the valuable information back to our planet. On Earth, sophisticated receiving stations intercept and decode the transmitted data, preparing it for in-depth scientific analysis and interpretation. What makes these tapes truly extraordinary is their robust construction, specifically tailored to withstand the harsh conditions of space. They typically consist of a metallic base layer, often made from materials like stainless steel, renowned for its resilience against radiation, extreme temperatures, and the vacuum of space. Each track on these tapes is coated with a magnetic material specially designed to preserve the integrity of the stored digital data, ensuring minimal degradation over time. Additionally, the tapes are encased in protective enclosures, shielding them from potential hazards such as micrometeoroid impacts, further enhancing their durability and reliability. Despite their vintage design, these 8-track tapes continue to operate seamlessly, dutifully transmitting crucial data back to Earth each day. The accomplishments of the Voyager spacecrafts have been truly amazing. When they first started exploring Jupiter and Saturn's moons more than 40 years ago, they amazed scientists and changed what we thought about these faraway places. Instead of being quiet and covered in craters like our moon, these moons turned out to be full of action, with lots of things happening on their surfaces. Voyager 2 especially hit some big milestones during its trip. In 1986, it became the first spacecraft to get close to Uranus. Just 3 years later, it flew past Neptune, a record that still hasn't been beaten. As these spacecrafts keep traveling, NASA has taken steps to keep them going. They've turned off some parts that aren't needed and heaters to save power. This means the Voyagers can keep working until at least 2030. For the scientists and engineers who have worked on this project from the beginning, it's a mix of happiness and sadness as they see it reach its end. They put in a lot of effort and went way beyond what they thought they could do. The data the Voyagers have sent back has been super valuable, leading to tons of new discoveries and getting people excited about space for years to come. You see, Voyager 1 and Voyager 2 weren't your average spacecraft. They were built with extreme precision, rotating at a speed more than 15 times slower than the hour hand of a clock. This slow rotation ensured that the images and data they collected during their space journey were crystal clear, without any blurriness. Their remarkable ability to capture images amazed both scientists and the public long before they reached the outer planets. Months before getting close to Jupiter, they started beaming back images of the gas giant, showing its swirling clouds and the famous Great Red Spot. These early glimpses were a hit at NASA's Jet Propulsion Laboratory, but what really stole the show was their discovery of active volcanoes on Jupiter's moon, Io. This moon, a bit bigger than our own moon, turned out to be the most volcanic place in our solar system. The spacecraft's instruments picked up strange signals from Io, which were confirmed by the stunning images they snapped. These images revealed towering volcanic eruptions and a surface scattered with volcanic material. One of Io's volcanoes, Hele, has erupted so high that it could cover an area almost as big as France. In total, the Voyager duo captured more than 33,000 images of Jupiter and its moons, showcasing the planet's beauty and the fascinating variety of landscapes across Jupiter's moons. Prior to the recent alerts, the twin Voyager spacecraft have been uncovering amazing things ever since they were launched. One of the big surprises was finding out that Jupiter has rings around it. These rings might be faint, but they're a big deal and make Jupiter even more fascinating. Voyager 2 also showed us that Europa, one of Jupiter's moons, has a really thick icy shell, more than 60 miles thick. This discovery shook up what we thought we knew about these faraway celestial objects and got scientists excited about whether icy moons like Europa could be places where life could exist. When the Voyagers left Jupiter, they got a boost from its gravity, like a goodbye push, that sent them flying towards Saturn. This boost was crucial because it helped them break free from the sun's pull and continue their journey into space. After saying goodbye to Jupiter, Voyager 1 and Voyager 2 went their separate ways. Voyager 1 swung by Saturn's moon Titan, covered in a mysterious orange haze, sparking scientists' curiosity about its complex chemistry. Then, it headed upwards, leaving the planets behind and venturing into the unknown beyond our solar system. On the other hand, Voyager 2 went on a grand tour of the outer planets. It made history in 1986 by buzzing past Uranus and discovering 10 new moons there. That bumped up Uranus's moon count by quite a bit. 3 years later, Voyager 2 reached Neptune, showing us the incredible features of this icy giant from afar. During its visit to Neptune, Voyager 2 clocked wind speeds of up to 1,000 miles per hour, the fastest ever on a planet in our solar system. The spacecraft got as close as 2,980 miles to Neptune's blue methane-filled air, giving us new insights into this faraway place. Neptune's biggest moon, Triton, turned out to be one of the coldest spots around, with temperatures plunging to minus 391 degrees Fahrenheit on its surface. Triton also has some cool stuff like ice volcanoes shooting out nitrogen gas and icy bits, reaching 5 miles high in its thin air. These discoveries helped us see how diverse and complex our solar system's objects are, even out in the farthest reaches. Someone crucial in pushing these missions further was the famous astronomer Carl Sagan. He was part of the Voyager team and pushed hard to snap one last set of pictures before both spacecraft cameras shut down. His determination paid off, giving humanity a final look at our home planet from way out in space. Back in 1990, Voyager 1 turned its camera towards our solar system's inner parts and snapped 60 pictures. One of these pictures, famously called the pale blue dot, has become a symbol we can't forget, reminding us of where we stand in the vastness of space. Taken from an incredible distance of 3.8 billion miles, this image is the farthest one ever taken of our planet. In this picture, Earth looks like a tiny, pale blue dot, almost lost in the vastness of space. The Voyager spacecraft has given us new insights into how empty interstellar space really is. NASA's observations show that cosmic rays are 3 times stronger outside our solar system's protective shield, called the heliopause, compared to inside it. But there's more to this fascinating story. Scientists have combined Voyager's discoveries with data from later missions, uncovering a strange humming sound recorded by Voyager 1. This mysterious resonance seems connected to unusual waves found in tiny amounts of gas in the harsh conditions of interstellar space. However, not everyone agrees on where these strange sounds come from. Some passionate science fans believe they could be caused by beings from other worlds. For more than 4 decades, the Voyager missions have been on a mission to uncover the secrets of our solar system. What they've revealed has been astonishing and even a bit weird. Scientists have discovered that the heliopause, the boundary that separates our solar system from interstellar space, isn't a fixed line. It's a constantly shifting barrier that changes its shape over time. This unusual behavior has left experts puzzled and a bit worried about what it could mean for the future. In addition to this, the Voyager spacecraft has gathered incredibly valuable data about the sun and how it impacts our solar system. This information has given us a deeper understanding of how this massive celestial body influences everything around it. Perhaps the most surprising aspect is how the Voyagers have continued to operate in temperatures much colder than they were designed for, challenging our usual expectations of technology's capabilities. As scientists combine Voyager's data with findings from other missions, they're starting to create models that predict how the heliopause might change in the coming years. However, the unpredictable nature of these forces means we can't predict with certainty what lies beyond the edge of our solar system. Recent discoveries about the heliopause have left scientists amazed and curious. They were taken aback by the surprising findings from the Interstellar Boundary Explorer in 2014. This spacecraft noticed a brightening of energetic neutral atoms, indicating that the heliopause had unexpected asymmetries that didn't match previous predictions. What's even more intriguing is the rapid changes detected by Voyager 1 and Voyager 2 in the heliopause. This unexpected evolution, known as entry speaking, has sparked a renewed interest among researchers to delve deeper into the celestial boundary. However, the real shocker came last year, when Voyager 1's Attitude Articulation and Control System, AACS, started sending garbled data instead of its usual operational updates. It was as if the spacecraft had developed a communication problem similar to electronic aphasia in humans, hindering its ability to convey coherent information. This anomaly has left engineers scratching their heads, wondering if the data received is merely chaotic or if it holds hidden patterns. Despite these challenges, scientists are eagerly anticipating the launch of NASA's Interstellar Mapping and Acceleration Probe, IMAP, in 2025. This new mission aims to unravel more mysteries surrounding the heliopause and the distant reaches of our solar system. In 2019, a concerning event shook the spacecraft that had been navigating interstellar space for the past 10 years. Despite regular status updates from the onboard system, the spacecraft's radio signal remained strong, indicating its overall health. However, NASA engineers encountered an unexpected issue with the Attitude Articulation and Control System. Instead of transmitting routine health and status data, the system started sending confusing and chaotic information. It turned out that a malfunctioning computer was corrupting all outgoing data, leading to this puzzling situation. Although the system has been fixed, the root cause of the malfunction remains a mystery, creating an intriguing puzzle for the team. Imagine the unsettling scenario of being alone in the vast darkness of space while your own systems start malfunctioning in inexplicable ways. This uncertainty raises questions about what else could go wrong beyond the protective reach of the sun's magnetic field. Despite these challenges, NASA's engineers had designed the spacecraft with a keen eye on potential encounters with extraterrestrial life. They were confident in Voyager's ability to navigate these unknown realms of interstellar space, keeping the possibility of alien encounters at the forefront of their design considerations. As Voyager 1 and Voyager 2 ventured beyond the protective boundaries of our heliosphere, they carried a captivating message from Earth in the form of the Golden Record. This record wasn't just any ordinary artifact. It was a deliberate invitation to any intelligent beings that might come across it during their cosmic journey. The Golden Record serves as a time capsule, capturing the essence of humanity. It includes a mesmerizing collection of sounds and images that reflect the diversity of human civilization and our interconnectedness with the universe. From the timeless music of Beethoven to the serene melodies of Guanpinghu's flowing streams, from heartfelt greetings in 55 languages to the captivating sounds of Earth such as thunder, birdsong, and laughter, it encompasses a rich fabric of our existence. Even more fascinating is that the Golden Record provides visual instructions on how to play it, ensuring that even curious extraterrestrial beings can access its contents should they encounter it. As Voyager embarked on its journey, the prospect of an encounter with an alien civilization became tantalizingly real. While the likelihood of such an encounter in the vastness of interstellar space is slim, it's not impossible. Space's immense scale means that even at the speed of light, it would take considerable time for a signal to reach Voyager from Earth. This raises the intriguing possibility that an alien civilization might intercept Voyager and respond before we even receive their message. The James Webb Telescope, our window into deep space, has made a discovery that echoes through the field of astrophysics, a finding with big implications for the future of the Andromeda Galaxy. This galaxy, once seen as proof of our place in the universe, now pushes the limits of what we know and raises interesting questions. What could be the cause of this potential destruction? How would it affect the billions of stars and the planets around them? Join us as we uncover jaw-dropping revelations about Andromeda that will reshape your view of the stars above. The cosmos continues to hold untold stories, waiting to be unraveled, especially when we reflect on human history and space exploration. Just 100 years ago, our ancestors gazed at the Milky Way and saw it as a faint streak of light, a blurry and mystical band veiling the true brilliance beneath. Many saw it as a place where our world met the divine, the epicenter of creation itself. However, everything changed with the revelations brought by the James Webb Telescope. In the 17th century, Galileo Galilei, a visionary Italian astronomer, peered through an early telescope and shattered the illusion. What was thought to be a diffused light turned out to be billions of stars, planets, and celestial marvels comprising the Milky Way. The Andromeda Galaxy, our closest neighbor, is just one among approximately 100 billion galaxies in the visible universe. The sheer number of stars out there is mind-boggling. Previously, we believed the Milky Way to be the universe's focal point, a special hub. However, Galileo's revelations rocked the scientific community by revealing that it's merely a vast collection of stars scattered across space. Then, in 1750, English astronomer Thomas Wright added another layer to this cosmic saga. He proposed that the Milky Way isn't a chaotic jumble of stars, but a flat layer, with a portion of it housing our own solar system. It's incredible to think how limited our understanding was due to technological constraints. For a long time, we thought the Milky Way encompassed everything. But as technology surged forward, especially by the early 1900s, the universe unfolded its secrets, leaving us humbled and amazed. One of the most shocking revelations came from the Hubble Space Telescope, which showed us the grandeur of the Andromeda Galaxy, a cosmic giant akin to our own Milky Way. In the vibrant era of the 1920s, Edwin Hubble, an esteemed American astronomer, ventured into the cosmos using the Hooker telescope, a colossal instrument for celestial observation. Amidst the vast expanse of the night sky, Hubble's keen eyes discerned hazy, distant formations that led to an astounding revelation. These were not mere extensions of our own Milky Way galaxy. They were distinct galaxies in their own right, each hosting billions of stars in their cosmic embrace. Among Hubble's remarkable findings stood the Andromeda Galaxy, also known as M31. However, Andromeda was no newcomer to humanity's stargazing pursuits. Centuries earlier, during the 10th century, the perceptive Persian astronomer Abdul Rahman al-Sufi had observed this celestial marvel with unaided eyes, likening it to a diminutive cloud. Such was the grandeur of Andromeda that it remained visible from Earth without the aid of sophisticated instruments. A clear night sky and a bit of astronomical knowledge were all that was needed to marvel at its splendor. Fast forward to the 1600s, and the Italian observer Simone Marius delved deeper into Andromeda's secrets using a telescope, unraveling fascinating details about this enigmatic galaxy. It wasn't until 1764 that Charles Messier, a prominent figure in the realm of astronomy, bestowed upon it the designation M31. The twist in this cosmic tale adds a layer of intrigue. Despite Messier's attribution, the galaxy had already been noted by Al-Sufi centuries earlier. In 1864, the brilliant English scientist William Huggins conducted a close examination of the light emitted by Andromeda, leading to a groundbreaking revelation. He discovered that Andromeda's light differed significantly from that of other celestial bodies, marking a pivotal moment when the world began to comprehend the true uniqueness of this cosmic entity. Andromeda's sheer size is nothing short of astounding. To put it into perspective, consider the mass of our own sun. Now envision a mass that ranges between 1 and 2 trillion times greater than that of the sun. That immense scale is what defines Andromeda, a colossal celestial body that commands admiration and respect. Not only is Andromeda massive, but it also holds ancient origins, dating back approximately 10 billion years. This extensive timeline encapsulates a wealth of cosmic history, making Andromeda a repository of ancient cosmic events and phenomena. One fascinating theory proposed by researchers delves into the formation of Andromeda. What if this colossal galaxy emerged from the merger of several smaller galaxies, a cosmic collaboration spanning billions of years? It's akin to a grand cosmic team-up, where gravitational forces gradually drew these smaller entities together, culminating in the birth of the majestic Andromeda we recognize today. This process of galactic mergers, while awe-inspiring, isn't uncommon in our expansive universe. Picture two immense galaxies engaging in a slow, gravitational dance, akin to giant cosmic whirlpools irresistibly drawn toward each other. However, this dance unfolds over such vast timescales that we are unable to witness it in real time. By the time significant changes become noticeable, a substantial portion of the merger has already transpired. For a considerable period, Andromeda was regarded as the elder sibling, towering over our Milky Way galaxy in size and stature. When you gaze up from Earth at the Andromeda Galaxy, its vastness and splendor can easily lead you to think that our own Milky Way pales in comparison. However, recent discoveries have shaken up this belief. Scientists now suggest that the Milky Way might be just as massive as Andromeda, turning our previous assumptions on their head. Think about standing on a planet within Andromeda and looking back towards Earth. Suddenly, our galaxy doesn't seem so diminutive anymore. It holds its ground in grandeur. It's akin to finding out that your younger sibling isn't as little as you once thought. Yet in terms of sheer physical dimensions, Andromeda does have the upper hand. Its diameter spans approximately 220,000 light-years, eclipsing the Milky Way's range of 100,000 to 175,000 light-years. Picture it as if galaxies were urban landscapes. Andromeda sprawls across a vast territory, while the Milky Way is more densely packed with stars. These revelations shed light on the complexities of measuring galaxies. They are colossal entities, brimming with stars, gases, dust, and enigmatic dark matter. Determining their mass accurately is akin to attempting to count every grain of sand on a beach, with added layers of complexity. Such precision in measurement was unimaginable in earlier centuries. It took the advent of modern-day tools to unveil these astounding truths. For instance, the Andromeda Galaxy houses an active galactic nucleus, akin to a beating heart, emitting intense light across various wavelengths, from radio waves to X-rays. The presence of a supermassive black hole, weighing millions of times more than our sun, adds to the spectacle. Most galaxies, including the Milky Way, host such gargantuan black holes at their cores. These aren't mere cosmic vacuums, they significantly influence the structure and evolution of galaxies. What's even more captivating is how stars and gases interact with these black holes. Instead of being swallowed whole, they form accretion disks, akin to neon signs in space, shining brightly and announcing their presence to the universe. These disks, along with stars orbiting these black holes in complex trajectories, create breathtaking phenomena observed in galaxies like Andromeda. During their closest approach to the black hole, stars experience intense gravitational forces, akin to the universe's most powerful magnet pulling them in. This interaction leads to the release of energy in bursts, illuminating the galaxy in a dazzling display. When we peer into the heart of Andromeda and witness the twin lights dancing, we're actually observing a spectacular performance that has been unfolding for billions of years. This cosmic ballet unveils the intricate relationship between stars and the monstrous black hole at the center of the galaxy, offering insights into the cosmic dynamics at play in our vast universe. And the most astonishing part? This celestial show is happening right in our cosmic neighborhood. But wait, there's more to Andromeda's allure. Beyond its mesmerizing beauty, this galaxy harbors a hidden treasure trove of globular clusters. These clusters can be envisioned as tightly knit stellar communities, acting as satellites, encircling the galactic core in a mesmerizing dance. Just imagine, around 460 of these star-studded clusters, each brimming with hundreds of thousands to millions of stars, all born during the same cosmic era. The sheer abundance of these clusters unveils incredible tales about Andromeda's cosmic history. It hints at a galactic narrative akin to a cosmic bully. Over eons, Andromeda has engaged in what astronomers term galactic cannibalism, a process where its immense gravitational pull strips stars from smaller neighboring galaxies that venture too close. These stars, enticed by Andromeda's gravitational embrace, join its already vast and diverse stellar community, enriching the galaxy's cosmic fabric. Visualize Andromeda as a celestial collector, continuously amassing stars and clusters, expanding its cosmic portfolio. This characteristic isn't unique to Andromeda alone. Spiral galaxies, with their iconic swirling arms and flat, disc-like structures, serve as ideal arenas for these dramatic cosmic encounters, painting a vivid picture of the dynamic and ever-evolving nature of our cosmic landscape. Some experts are now proposing a fascinating idea about the Andromeda Galaxy. It's undergoing an extraordinary transformation, morphing from a typical spiral galaxy into a rare and enigmatic ring galaxy. These ring galaxies are like the unicorns of the universe, adorned with bright, youthful blue stars arranged in a distinctive ring pattern, while their centers remain shrouded in darkness, adding an air of mystery and allure. These cosmic celebrities stand out amidst the ordinary galactic crowd, showcasing three primary types of rings: nuclear, inner, and outer, each with its own unique characteristics. Nuclear rings snugly encircle the galaxy's core, while inner and outer rings extend further out. Delving deeper, ring galaxies come in two flavors: O-type and P-type. O-type galaxies feature a central nucleus with smooth, symmetrical rings, while P-type galaxies are more erratic, with off-center nuclei and asymmetrical rings. What's truly remarkable is that only a minuscule fraction of galaxies, roughly 1 in 10,000, earn the prestigious title of a ring galaxy. But how do these celestial marvels come into existence? There are two primary theories that astronomers propose. One involves a cosmic collision, where two galaxies collide, and the aftermath gives rise to a ring galaxy, as seen in examples like the Cartwheel Galaxy and ARP-147. Another scenario involves a smaller galaxy zooming through a larger one, creating the captivating ringed beauty we observe. However, what makes this cosmic narrative even more thrilling is the impending collision between our own Milky Way and the neighboring Andromeda Galaxy. They are hurtling towards each other, destined for a dramatic cosmic merger that will transform them into a colossal mega-galaxy. This cosmic dance has sparked imaginative nicknames like Milkometer or Milkdromeda, reflecting the awe and anticipation surrounding this monumental event. While these names may sound whimsical, the reality of such a cosmic encounter is nothing short of jaw-dropping. As these galaxies converge, their immense gravitational forces will distort and reshape their structures, creating a cosmic ballet where stars, gas, and dust swirl, collide, and merge in a spectacle of galactic mayhem. This collision won't just be a dance of stars, it will be a cosmic symphony of creation, destruction, and transformation on a truly epic scale, offering a glimpse into the dynamic and ever-changing nature of our vast universe. The collision course between the Milky Way and Andromeda is like witnessing two colossal whirlpools of stars, black holes, and gas spiraling into each other, creating a cosmic spectacle of epic proportions. At the core of these galaxies lie supermassive black holes, akin to monstrous cosmic drains, which will merge during this collision to form an even more immense black hole. The resulting event is akin to an otherworldly fireworks display, dazzling observers with its sheer magnitude and cosmic drama. However, the impact of this cosmic collision isn't limited to the celestial realm. The night sky that has been familiar to us for millennia will undergo dramatic changes. New constellations will illuminate our nights, and the sky will be adorned with fresh star clusters and radiant bursts, transforming the celestial panorama we've long been accustomed to. Yet, the implications of this cosmic dance extend far beyond a mere shifting light show. Earth itself will bear the consequences of these distant, celestial events. The very environment of our planet will undergo vast transformations. Regions where life thrives may experience upheavals, leading to altered habitats and potential local extinctions. Weather patterns could become erratic, with abrupt shifts in temperature and rainfall, challenging the adaptability of plants and animals and disrupting the delicate balance of ecosystems. The ozone layer, crucial for shielding life on Earth from harmful cosmic radiation, may face heightened risks due to the increased cosmic activity resulting from the galactic collision. Picture a world where our daily lives are influenced by the ever-changing climate and ecosystems. Animals, driven by the need to find suitable habitats, food, and water, embark on migrations disrupted by the changing landscape. Their traditional routes may vanish or shift entirely, forcing them to adapt to unfamiliar territories. This ripple effect extends throughout the circle of life, impacting biodiversity as some species thrive in the new environment, while others struggle to survive, potentially leading to local extinctions. The interconnectedness of species within an ecosystem is profound, where the struggles of one can ripple through and affect others, potentially leading to the disappearance of certain animals from specific regions. However, while this scenario paints a dramatic picture, something even more awe-inspiring is on the cosmic horizon, a collision between entire galaxies. But before you start packing your bags for this cosmic event, let's clarify a crucial point. This galactic collision isn't imminent. It's set to commence approximately 4 billion years from now, with the entire cosmic dance lasting another 2 billion years. By that distant time, humans, as we currently know them, will be but a footnote in the vast history of the universe. Moreover, consider our sun, that familiar warm orb in the sky. In about 5 billion years, it's forecasted to undergo a dramatic transformation, swelling into a red giant and potentially engulfing Earth, rendering our solar system uninhabitable long before the galactic merger begins. Now let's delve into this cosmic ballet between the Andromeda Galaxy and our Milky Way. As these two galactic giants converge, a magnificent interaction of stars, gas, and dust will unfold, forging a new galactic structure unlike anything witnessed before. Within this cosmic cauldron of stars and planets, there may be special regions where conditions are conducive to life. However, it's a gamble, as planetary orbits and environments could be disrupted, reshaping the potential habitats for life. Additionally, space isn't always silent. Events like supernovae and gamma-ray bursts may illuminate this new galactic landscape, influencing any potential planets and their ecosystems. The universe is a fabric woven with mysteries, wonders, and breathtaking events waiting to unfold. While we may not be present to witness this grand galactic collision, the mere knowledge that such a spectacular celestial dance will transpire is both captivating and mind-boggling, underscoring the boundless marvels of our cosmos. The forthcoming collision between our Milky Way and the Andromeda Galaxy, slated to occur in roughly 4 billion years, has captured the attention of astronomers and space enthusiasts worldwide. This cosmic event, steeped in mystery and anticipation, fuels both scientific inquiry and contemplation about the future of space exploration. As humanity delves further into the vast expanse of space, comprehending such intergalactic phenomena becomes not just a matter of scientific interest, but also a potential puzzle for civilizations yet to come. This collision, on a scale that spans entire galaxies, presents a mix of challenges and opportunities that cannot be overlooked. From the perspective of space travel, this cosmic merger brings forth a complex dance of forces. On one hand, the gravitational disruption stemming from the merger could upset established space pathways, navigation protocols, and the delicate balance of planetary orbits. This upheaval could jeopardize habitats or settlements that have evolved over millennia in certain star systems, facing existential risks as celestial bodies, interstellar dust, and gas clouds collide and intermingle. Yet, on the flip side of this cosmic coin, the merger also heralds potential benefits. The merging of galaxies could unveil new realms within the amalgamated galaxy, ripe for exploration, and perhaps even colonization. As the galactic giants converge, previously distant star systems will draw closer, potentially easing the challenges of interstellar travel between specific regions. Navigating this impending collision will require a blend of foresight, innovation, and adaptability. Astronomers and space agencies must anticipate the disruptions to space infrastructure while also exploring the newfound possibilities that arise from this cosmic convergence. The collision of the Milky Way and Andromeda galaxies could spark a renaissance in space exploration and colonization, unlocking zones that were previously beyond reach. This cosmic event holds the promise of providing first-hand insights into stellar evolution, planetary formation, and the enigmatic nature of dark matter. By observing this monumental collision up close, scientists can make groundbreaking discoveries and gain a deeper understanding of how our universe functions. While the concept of galaxies colliding might evoke images of cataclysmic destruction, the immense scale of space means that many stars will pass each other without direct collisions. However, the gravitational forces at play will cause stars to relocate, resulting in a reshuffled arrangement of the Milky Way and Andromeda's stellar populations. For space travelers of the future, this merger presents both an era of unprecedented exploration opportunities and a period of significant adaptation. Navigating through the shifting cosmic landscape will require innovative strategies and a keen understanding of the new dynamics at play. Yet, it also offers unique chances to explore uncharted territories and study the effects of galactic mergers firsthand. As the Milky Way and Andromeda merge into a new cosmic entity, the ever-changing nature of the universe will undoubtedly continue to inspire awe and wonder among those venturing through the vastness of space. This collision represents not just a singular event, but a chapter in humanity's ongoing quest to unravel the mysteries of the cosmos and expand our horizons beyond Earth. Astronomers are on high alert as Oumuamua, the mysterious interstellar object, hurtles towards Earth. This interstellar visitor, once a source of curiosity, now sparks fear as experts proclaim its inevitable crash. Can humanity do anything to alter this cosmic fate? How do we face the countdown to impact? Let's delve into these unsettling predictions and explore the implications of Oumuamua's imminent impact on our world. Back in 1837, there was a mysterious event in space that went unnoticed by everyone. An object, far away from the sun, made a significant journey of 1,000 astronomical units. This object continued its silent approach towards Earth for over a century, eluding the detection of scientists. It wasn't until October 19, 2017, when Robert Werke, a scientist in Hawaii, finally spotted it. Using an astronomical telescope at the University of Hawaii, Werke captured an image revealing a faint streak moving steadily across the sky each day. This discovery marked a historic moment as it became the first recorded interstellar visitor. The discoverer, contemplating the significance of this find, named it Oumuamua, which translates to messenger from afar. Despite its Hawaiian origins, Oumuamua's discovery sparked a global effort to observe it through various telescopes. Astronomers from the SEI Institute also joined in, eager to study the object and search for signs of extraterrestrial activity. Now, what does Oumuamua actually look like? Some describe it as a reddish, cigar-shaped rock with dimensions that surpass any known asteroid or comet in our solar system. Its elongated form stretches almost 4 miles wide, making it 10 times longer than it is wide. This unusual shape and size prompted debates among scientists about whether Oumuamua was an asteroid or a comet. Asteroids are small rocky bodies orbiting the sun, while comets are larger objects made of dust and ice. Oumuamua's remarkable speed of 196,000 miles per hour, over 100 times faster than a speeding bullet, set it apart from typical celestial objects in our solar system. Initially thought to be a comet, scientists later classified it as an asteroid after it passed close to the sun. However, subsequent observations revealed a slight acceleration, leading to renewed debates about its nature. The periodic brightening and dimming of Oumuamua every 7.3 hours hinted at its rotation around its axis. This unique pattern suggested a composition different from typical comets, indicating a more durable structure. Its dark red color, similar to moons affected by space radiation in the outer solar system, raised speculations about its origins. Amidst these scientific discussions, some theories ventured into more imaginative realms, suggesting the possibility of Oumuamua being an alien spacecraft or even a Russian creation due to its iron-rich composition. Dr. Mack, an astronomer from the University of Hawaii Institute, hinted at the iron content contributing to Oumuamua's distinct coloration, adding fuel to the speculation. Various ideas surfaced regarding what Oumuamua could be. Some thought it might be a rock, while others suggested it was filled with gas. Then came the surprising notion that it could be an alien spacecraft. This leads to the intriguing possibility of an alien vessel lurking nearby, perhaps releasing parts to explore Earth. But is this really the case? Let's delve deeper into these ideas to uncover more. Dr. Mack proposed that Oumuamua was flung from a distant star after a supernova explosion. On the other hand, Elon Musk suggested it formed from a collision and fusion of two objects. Initially, astronomers were excited to find that Oumuamua seemed to point towards Vega, the brightest star in the Lyra constellation, known for its debris disk. Calculations hinted it could have traveled here in about 600,000 years. However, this Vega connection was later questioned due to significant deviations in its path, suggesting encounters with other star systems. One theory posits Oumuamua as a chunk of nitrogen ice, possibly a fragment from a Pluto-like object, impacted by a cosmic event, although this would require it to be smaller than initially estimated. Another theory involves cosmic rays interacting with surface ice in interstellar space, releasing trapped hydrogen gas from water molecules, proposed by researchers Alan Jackson and Stephen Desch. A more captivating idea comes from Daryl Seligman and Jennifer Bergner, suggesting Oumuamua gained momentum from the sun, altering its icy structure and propelling it forward. But this hinges on the assumption that it's primarily composed of ice. Avi Loeb and Shmuel Bialy from Harvard University sparked further intrigue by proposing Oumuamua as a solar-powered spacecraft, citing its unusual characteristics hinting at extraterrestrial origins. Despite these theories, Oumuamua's true nature remains elusive due to its mysterious size and shape. No direct image has been captured, leaving astronomers to estimate its properties based on brightness and light reflection patterns. The lack of a tail or coma discounts the comet theory, leading to speculation about solar radiation pressure causing its movements, akin to light sail technology used in space missions. This uncertainty fuels questions about Oumuamua's origin, purpose, and final destination. Is it heading towards a crash, possibly on Earth? Scientists grapple with these questions, analyzing its trajectory and behavior to understand its potential impact. Scientists once considered sending robotic probes, with sails speeding toward Oumuamua. Sadly, this idea isn't feasible right now. Why? Because we haven't yet developed aircraft capable of such a mission. However, there's hope for the future, with projects like Breakthrough Starshot actively exploring this possibility. Whether or not scientists eventually reach Oumuamua, its visit can serve as valuable preparation for future encounters. Oumuamua's journey to its current location took billions of years, yet in the grand cosmic scheme, it's but a fleeting moment. The Milky Way galaxy, spanning an impressive 10 billion years, hints at Oumuamua's potential journey through around 20,000 star systems. While this seems significant, it's merely a small fraction compared to the galaxy's staggering 200 billion stars. Still, it marks numerous cosmic encounters for Oumuamua, potentially influencing the intermingling of stars through the dust and debris it leaves in its wake. Elon Musk and other astronomers speculate that Oumuamua is racing towards Earth, with predictions even suggesting its entry into the Kuiper Belt year. Despite these projections, Oumuamua remains elusive, with scientists relying on gathered data to track its movements and potential approach towards Earth. What sets Oumuamua apart is its unconventional trajectory, characterized by a noticeable non-gravitational acceleration. This acceleration, beyond gravitational forces, has puzzled scientists. Dr. Mech, exploring potential causes, proposed 6 factors that could contribute to this anomaly. One such observation is similar to the outgassing seen in comets, when surface ice sublimates into gas near the sun, providing an extra push altering its speed and rotation. While similarities to cometary behavior exist, the absence of detectable gas emissions and significant dust particles raises doubts about Oumuamua's classification as a comet. The lack of CN gas typically associated with comets in our solar system suggests that Oumuamua might be chemically distinct, challenging previous assumptions. Efforts to observe Oumuamua's thermal characteristics using the Spitzer Space Telescope yielded limited results. The absence of noticeable heat emissions, despite expectations based on cometary behaviors, adds to the mystery surrounding this interstellar object. Its reflectivity, crucial in determining size, composition, and shape, remains a topic of speculation. Despite numerous theories and observations, Oumuamua's true nature eludes us. Initially categorized as an asteroid, then possibly a comet, and even speculated as an alien spacecraft by some, Oumuamua has intrigued astronomers with its enigmatic journey through our solar system. Observations during its brief visit revealed a hyperbolic orbit, indicating that it originated from beyond our solar system and was merely passing through, never to return. However, this conclusion raises questions about whether Oumuamua will truly never be seen again. One of the fascinating aspects of Oumuamua is its increasing speed as it rounded the sun. While gravitational forces from larger celestial bodies typically accelerate smaller objects like comets and asteroids, Oumuamua's velocity far exceeded that of an average comet in our solar system. This acceleration puzzled scientists, challenging existing theories and prompting a reevaluation of Oumuamua's classification. Many scientists lean towards considering Oumuamua a comet rather than an asteroid due to its observed acceleration. Comets in our solar system gain momentum from the evaporation of water and dust near the sun, creating distinctive tails. Yet Oumuamua displayed no such tail, complicating the classification further. Numerous theories attempting to explain Oumuamua's acceleration have fallen short, leaving a significant gap in understanding. In a recent study, Jennifer Bergner from the University of California, Berkeley, and Daryl Seligman from Cornell University proposed a novel theory. They suggest that Oumuamua's chemistry may not be extraordinary. Instead, it could have undergone processes beyond our solar system, influenced by cosmic radiation. Their theory posits that as a comet travels through the interstellar medium, cosmic radiation can induce hydrogen formation within the comet. Upon entering our solar system and warming up, this trapped hydrogen could lead to outgassing, potentially explaining Oumuamua's acceleration. Experimental studies supporting this idea highlight the role of high-energy particles in splitting molecular hydrogen from water ice and trapping it within the comet. While some scientists remain skeptical, citing challenges such as surface temperature miscalculations, this new perspective offers a plausible explanation for Oumuamua's behavior. The ongoing debate underscores the complexity of interstellar objects and the need for further research. As Oumuamua continues its journey beyond our reach, astronomers eagerly await new interstellar visitors that could shed light on unanswered questions. Advanced telescopes expected to come online in the coming years hold promise for unraveling mysteries within our Milky Way galaxy. Meanwhile, amidst the discussion on Oumuamua's nature, another intriguing discovery emerged. It was not alone. In 2019, amateur astronomer Gennady Borisov made a remarkable discovery at the Margot Observatory in Crimea, a new comet named 2I Borisov. The moniker 2I stems from its status as the second interstellar object observed after Oumuamua. What set 2I Borisov apart was its extraordinary speed, racing through space at a staggering 93,000 miles per hour, significantly faster than typical objects at that distance from the sun. What caught scientists' attention, even more than its speed, was its trajectory, a high eccentricity orbit of 3.7 and a 40-degree inclination to the ecliptic plane, indicating an extrasolar origin akin to Oumuamua. Unlike Oumuamua, Borisov was unmistakably identified as a comet due to its distinct tail. As it approached the sun, it brightened before dimming, possibly reaching magnitude 15 by its closest pass to Earth in December 2019. Despite its fading visibility for amateur watchers by October 2020, experts continued tracking Borisov, noting CN gas emissions from its surface. This extensive observation, facilitated by the 2I's trajectory, provided a unique opportunity to study its chemistry in depth. This investigation revealed 2 key aspects. First, Borisov's comet-like appearance with a reddish hue aligns more closely with conventional solar system comets, showcasing the diversity of interstellar objects. Such distinctions are vital for astronomers seeking insights into the formation processes of other solar systems, broadening our understanding of the universe's vast complexities. Meanwhile, amidst the intrigue surrounding Borisov, speculation about Oumuamua's extraterrestrial origins persists. A Harvard scientist article and the head of the Pentagon's UFO office have even suggested the possibility of an extraterrestrial mothership in our solar system, dispatching tiny probes akin to dandelion seeds to explore planets. This speculation has intensified with the establishment of the Pentagon's All-Domain Anomaly Resolution Office in July 2022, aimed at identifying and researching intriguing celestial objects. Avi Loeb, a scientist not typically associated with Oumuamua, became captivated by a meteor named M2. He pondered the potential for an artificial object of interest to serve as a primary craft, deploying numerous small probes as it passed near Earth, a concept akin to NASA's spacecraft missions. In a preliminary study authored by Kirkpatrick and Loeb, they explored unidentified anomalous phenomena, a term preferred by the government for UFOs, while adhering to established physics principles. They speculated that the craft's propulsion, or the gravitational forces from the sun, could detach tiny probes, akin to dandelion seeds, from their parent vessel. These scientists theorized that due to their diminutive size, which would limit their sunlight reflection, the dandelion-like probes might journey to Earth undetected by survey telescopes. According to their hypothesis, the probe's technology could facilitate a controlled descent in Earth's atmosphere to prevent burning, followed by a parachute-like landing. The notion arises from scientific conjectures that extraterrestrial civilizations might be intrigued by our solar system's rocky planets, with atmospheres, including Mars, Venus, and Earth. The intelligent extraterrestrial society behind these probes might not need to remain aboard the mothership after discovering evidence of liquid water. Communication between the mothership and these probes is deemed unlikely. Loeb analogizes this scenario to periodically checking one's mailbox for packages, even if the senders are no longer present. Despite encountering skepticism from the scientific community after proposing that Oumuamua might be an alien spacecraft, Loeb persists in his exploration. In 2021, a letter published in the journal Astronomy and Astrophysics dismissed the possibility of interstellar travel due to cosmic timescales. This letter favored the hypothesis that Oumuamua's peculiar movements were caused by a rock rather than an alien civilization. A subsequent analysis attributed Oumuamua's behavior to hydrogen off-gassing on March 22, 2023, refuting the alien spacecraft theory. However, the Pentagon has intensified investigations into mysterious aerial phenomena within U.S. airspace through the All-Domain Anomaly Resolution Office, launching over 360 new inquiries into unexplained incidents involving military personnel. Elon Musk and others advocate for advanced telescopic scanning to identify potential alien objects, offering opportunities to test hypotheses and expand astronomical knowledge, reminiscent of the rapid advancements seen in exoplanet research over the past 2 decades. These discussions have also sparked debates on the theoretical feasibility of reaching Oumuamua, including concepts like wormholes. To venture into the realms of Oumuamua, the creation of spacecraft capable of such exploration is imperative. While the notion of dispatching a craft after the asteroid probe is plausible, it presents formidable challenges. Oumuamua's trajectory, with a hyperbolic excess velocity of 5.5 AU per year, will carry it beyond Saturn's orbit within 2 years. This pace far exceeds any previous human-launched space missions. The question arises, what type of vessel is equipped for such an endeavor? Should we rely on conventional propulsion methods like solar sails, or should we entertain more exotic possibilities such as wormholes? The concept of wormholes, proposed by Nathan Rosen and Albert Einstein in 1935 within the framework of general relativity, offers tantalizing prospects. These Einstein-Rosen bridges, or wormholes, theoretically connect disparate points in space-time, potentially providing shortcuts across vast cosmic distances. However, the practicality of wormholes is marred by numerous complexities. Issues such as collapse risks, connections to unknown realms, and the technical challenges of construction cast shadows of uncertainty. Despite their theoretical allure, no verifiable instances of wormholes have been observed or confirmed. The theoretical link between wormholes and black holes adds further intrigue, although the fate of objects or individuals entering black holes remains a mystery. Einstein's groundbreaking theory of spacetime as a dynamic fabric manipulated by mass and energy underpins the concept of wormholes. This manipulation creates gravitational valleys that influence celestial bodies' movements, suggesting the plausibility of wormhole formation. Wormholes are envisaged in various forms, classified by their characteristics. Traversable wormholes, akin to those often depicted in science fiction, offer potential avenues for interstellar travel. However, the feasibility of such journeys is subject to ongoing scientific scrutiny and debate. One-way wormholes hint at unidirectional travel, requiring complementary exits for return trips. Conversely, two-way wormholes facilitate round-trip voyages, providing continuous access to distant locales within our universe, or potentially bridging parallel realities. While these concepts fuel imaginative explorations in art and entertainment, their actual existence remains speculative. Wormholes' hypothetical locations within celestial phenomena, like black holes or white holes, contribute to their enigmatic allure. The scientific community grapples with such enigmas, akin to the puzzles of dark matter and dark energy, which, though theoretically conceivable, elude direct observation. Einstein's theory of general relativity provides a robust framework for wormhole speculation, yet ongoing research and inquiry are essential to unraveling these cosmic mysteries. Wormholes are like shortcuts in space-time, as per Einstein's idea. One reason we haven't found any yet could simply be because we haven't looked hard enough, not because they're impossible. Some science fiction shows and movies depict spaceships creating their own wormholes, which might be something we have to do since we haven't found any natural ones. Alternatively, natural wormholes might already exist, but we haven't discovered them yet. You might wonder, how could we miss a wormhole? Well, space is huge, trillions of light years across. We can only observe a small part of it despite our best efforts. Even though we can see planets and stars in distant galaxies, we keep finding new moons in our own solar system. With our limited ability to explore space, it's not surprising that some things go unnoticed. Why don't wormholes exist? The Big Bang Theory, which says the universe began with a huge explosion, is a likely explanation. Over billions of years, matter came together to form the cosmos we know. But this violent event might have left gaps in space-time, possibly connected by cosmic strings to form a network of wormholes waiting to be found. Think about how vast the cosmos is. How likely is it that one of the possibly many wormholes in the universe would be near us? And even if it were, could we spot it in the vastness of space? These questions show how hard it is to find wormholes, and how mysterious the universe is. Consider Star Trek. Wormholes in the show were only visible up close. Stable wormholes, like in Star Trek, The Next Generation, were rare and often led to unexpected adventures. Maybe we haven't found a wormhole yet simply because we haven't actively searched for one. Some scientists think wormholes, not black holes, might be at the centers of galaxies. This would mean cosmic strings connect all galaxies, a fascinating idea. Could a wormhole exist without outside influences? Gravity might oppose them, trying to pull everything together like with black holes. But some wormholes might persist, due to cosmic strings supplying energy to keep them open. It's exciting to think about the possibilities of wormholes, especially for space travel. Imagine creating a wormhole to reach Mars instantly, speeding up colonization efforts. While it's a dream for now, it's a dream that ignites curiosity and inspires exploration. Thank you for watching another episode of Voyager. While you are still here, click the video on your screen to see more mind-blowing videos like this one.